Investigators are piecing together how New York City's unique geology was formed. Much of its early success as a trade and commerce center is owed to its deep water harbor and its location at the coast. But 450 million years ago, things were different. The area of New York City was landlocked, embedded in the heart of a huge supercontinent. How did it get to the coast? The investigation fast-forwards 250 million years. In a quarry in New Jersey, 25 miles northeast of Manhattan, paleontologist Paul Olson unearths the first of a string of clues that could explain how New York City reached the coast. A giant fossilized footprint.
This is the footprint, actually the mud that filled in the footprint, of a 4-footed crocodile relative that was the dominant carnivore during the late Triassic. You can see the toes here have little pads on them, and here's the handprint. And these animals would have been, in this case, about the size of a modest crocodile, but some of them became much, much larger, the size even of a T-Rex.
The footprints are from a huge crocodile-like creature called Postosuchus. It first appeared on the Earth around 230 million years ago. Then, some 30 million years later, its footprints suddenly vanished. But Postosuchus wasn't alone. Half of all land animals perished at the same time. The fossil evidence proves it to be one of the biggest mass extinctions ever recorded.
The evidence for this mass extinction is that we have lots and lots of fossils right in this area. And what you see is, especially in the reptile footprints, you see one group of forms, the forms that are related to crocodilians, disappear.
Whatever caused the mass extinction must have been a catastrophic event. Olson had a hunch that the mass extinction was somehow related to New York's return to the coast. The ancient area of New York sat on a line of great weakness, the plate boundary where two continents joined to form the supercontinent Pangaea. And it was unstable, prone to earthquakes and volcanoes. Olson's quest to find the evidence for the natural disaster that finished off Postosuchus 200 million years ago. A band of dark rock above the footprints in the New Jersey quarry caught his eye. It was basalt, the smoking gun Olson was looking for. Basalt is a volcanic rock. It forms when hot lava erupts onto the surface and cools. Did the volcanoes that forged this basalt trigger the mass extinction and also rip Pangaea apart? On its own, the evidence at the quarry was unconvincing. The layer of basalt is only a few feet thick. To prove mass lava flows caused this global catastrophe, scientists needed corroborative evidence. High above the Hudson River, geologist Matt Goring follows another lead. He's studying the Palisades, a dramatic geologic feature that hugs the Hudson River, beginning across mid-Manhattan and running into northeast New Jersey. They too are made of basaltic rock, the same rock implicated in the mass extinction of land animals. But the Palisades are on an altogether different scale.
The Palisades are a sheet of basaltic magma about 1,000 feet thick. It's about 40 miles long, so it's a very prominent set of cliffs that run all the way up the west side of the Hudson River.
Here is proof of massive volcanic activity. Hot lava flooded out of ruptures in the Earth's crust and covered ancient North America in a mile-deep sheet. The lava cracked as it cooled. The vertical ruptures formed regular pencil-shaped columns. These distinctive rock formations have been known to geologists since the 19th century. Intriguingly, they appear on both sides of the Atlantic, in North and South America, Europe, and Africa. Geologists suspected that their presence pointed to the spot where Africa and Europe separated from America. But that was just an unproven theory. Until the 1950s, when scientists developed a revolutionary technique called paleomagnetism. Now, they could study the magnetic properties of rocks. Many rocks, including basalt, have a distinctive magnetic signature, formed as the rock is born. Tiny crystals inside the rock act like compass needles. When the magma that forms the rock is fluid, the crystals align to the Earth's magnetic field, pointing north. As the rock solidifies, the crystals freeze, forever locked in that fixed magnetic alignment. As continents move and the rocks travel, the crystals end up pointing in a different direction than north. Goring and his team investigate the magnetic signature of the Palisades. To get a sample, they bore into the rock with a water-cooled drill. They measure the exact orientation of the crystals today with a compass. When they offset this reading with magnetic north, they can calculate the original location of the rock.
14. One of the useful things that you can do with this rock is you can take it back in the lab and measure its magnetic orientation. And that magnetic orientation will be when this rock crystallized or solidified 200 million years ago. So this rock would have minerals that would be pointing in some other direction other than north today.
When scientists compared the magnetic orientation of the Palisades with the other basalt outcrops around the Atlantic, they discovered they formed at approximately the same latitude. Not only did the rocks have the same age, they were also born at the same location. For example, 200 million years ago, New York and Morocco were neighbors. The geologists had all the proof they needed. They could now confidently piece together what happened. It began with a global volcanic disaster.
About 200 million years ago, North America and Africa began to pull apart from each other. There were gigantic lava outpourings. These lava flows erupted along very long cracks in the Earth's crust that would have produced fountains of lava extending thousands and thousands of feet into the atmosphere. They covered an almost inconceivably large area, roughly 4 million square miles, from southwestern France to southwestern Brazil, from New York to central Mali in Africa. This area was covered in ponded lava flows that in some places ended up being nearly a mile thick.
Volcanic eruptions led to soaring temperatures. Half of the plants and animals died. Postosuchus didn't stand a chance. As enormous forces tore Pangaea apart, a giant sea formed between the separating land masses, the Atlantic Ocean. The city of New York was now at the coast. October 9th, 1992, Johnstown, Pennsylvania. Thousands of sports fans were watching their local high school football game when a dazzling meteor slashed through the skies. In only a few seconds, it traveled over eastern Kentucky, North Carolina, Maryland, and New Jersey. It became one of the most filmed fireballs in history. When it landed in Peekskill, New York, it smashed the trunk of a car. Luckily, no one got hurt. November 20th, 2008. An asteroid struck Earth again. A mighty fireball streaked over western Canada. As it dashed through the skies of Alberta, it broke into thousands of little pieces. It is the greatest number of fragments recorded from a single fall. Each year, almost 4,500 small-sized meteorites greater than 2 pounds each hit Earth. Over 99% of the impacts stay unnoticed, and damage is minimal. But on rare occasions, asteroids can be devastating. 13,000 years ago, the great ice sheets were in retreat as the last ice age was coming to an end. The Clovis people, one of the first human inhabitants of North America, roamed the Great Plains alongside giant beasts. A team of archaeologists is investigating the evidence they left in the Sheridan Cave in Ohio, southwest of Lake Erie.
Clovis peoples were hunter-gatherers. In other words, they hunted wild game and they gathered wild plant foods. At this time period, there were animals we call the megamammals, which included large elephant-like creatures such as the woolly mammoth, as well as the American mastodon.
Then, suddenly, all evidence of the megamammals and the weapons used by the Clovis people disappeared. The same observation was made by geologists at other excavation sites across America. Tankersley is convinced a catastrophe drove the mammoths to extinction.
And it would have happened in a snap of a finger. Over 30 genera of megamammals went extinct, and the Clovis technology disappeared forever.
Clues to what happened came from another part of the cave. It's in a geological formation known as the Black Mat Layer. It is a dark line of rock packed with charred debris, and it suggests a violent death.
The black layer, which you see in this profile, is carbon, a high organic content. And what we're seeing is the remains of animals which were living at that time, which literally had the flesh burned off their bones. In order to do that, we're talking about somewhere between 500 and 1,200 degrees Fahrenheit.
The cause of the inferno has long been a mystery, but deep in these Ohio caves, Tankersley thinks he has found traces for an asteroid impact.
This is what's known as a magnetic susceptibility meter. It looks as at the degree of magnetism of the layers of the sediments. If we take a reading in the layer that predates the asteroid or comet strike, and we look at the reading, it's somewhere around 7. If we compare that at the Black Mat, where we're finding micrometeorites, we're looking at 50 times the magnetism of the layer before we have evidence of an asteroid or large comet.
Like at Meteor Crater in Arizona, Tankersley believes the asteroid brought in large amounts of iron, causing a strong magnetic field. As the asteroid entered the atmosphere, it burst into thousands of smaller micrometeorites. He believes that the impact annihilated the megamammals and brought the Clovis people to the edge of extinction. Skeptics within the scientific community doubt the theory. They think the devastation could have been caused by lightning or a wildfire started by the Clovis people themselves. But recently, further evidence for the destructive power of these killer rocks has been uncovered. In March 1994, Carolyn Shoemaker and a team of astronomers made an extraordinary discovery. They were observing and recording the night sky when a giant fireball approached Jupiter.
Here was this fuzzy bar of light, and I looked at it and thought, what on earth? It looks like a squashed comet, because it was fuzzy.
It wasn't quite an asteroid, but a comet with a tail. Now called Shoemaker-Levy 9, the comet's mixture of giant space rocks and ice was heading directly for planet Jupiter.
Very exciting. We had already been up on a high, and we went up even farther because This was so unusual. No one had ever actually seen a comet in orbit about Jupiter. Although we knew they had been there, no one had seen a comet impact another body in space.
For the first time, the whole world was watching rogue pieces of rock hurtling through space towards a planet. As they entered Jupiter's atmosphere, something incredible happened. The rogue pieces exploded, causing giant shock waves. They left a series of holes in Jupiter, each bigger than the Earth itself.
The impact on Jupiter was sensational. It was very large. You could see the dark spot, and you could see the first ring, and then you could see this cloud of dust.
The team had witnessed an airburst. As the giant fireballs approached Jupiter at high speed, they were slowed down by the planet's atmosphere. The energy of motion was converted into pressure and heat and resulted in a huge explosion. A similar airburst over Earth would annihilate all life on the planet. Physicist Mark Boslow works at the top-secret Sandia Research Laboratories in New Mexico. He's one of many defense scientists investigating the possibilities of such an Armageddon. Research suggests we might not be as safe as once thought. The investigation leads to a remote region of Siberia. On June 30th, 1908, a bright flash streaked through the skies. Seconds later, the sound of an explosion followed. The area of Tunguska was hit by an airburst. A devastating shockwave uprooted thousands of trees and flattened more than 830 square miles of taiga forest.
There is still some evidence. There are some of these trees that had all their branches stripped off in 1908, and those trees that have been dead now for 100 years are still standing.
Scientists assumed the destruction must have been caused by an asteroid of at least 100 feet. And they also believed asteroids of this size would hit Earth only once every 1,000 years. But in 2008, Boslow discovered something alarming. With advanced computer simulation, he calculated that a small meteorite of only 20 feet across could cause a Tunguska-like event.
The airburst was actually smaller than people have been thinking for the last 20 years or so. And the reason we think it was smaller was because of this neglect of the momentum that continued to carry the energy down. What I'm showing here is an asteroid coming from the upper right, and it's pushing down into the atmosphere, and about 7.5 miles above the surface it explodes. But you can see that it continues to push downwards. So all that energy is continuing to push downwards, and it's driving this shock wave ahead of it. The shock wave is a big blast of air, hurricane force winds. Now that's what blows the trees down.
Based on this theory, asteroids able to cause another Tunguska could statistically hit our planet every 100 years. If such an airburst happened over a populated area, the consequences would be devastating.
Well, if something like this were to hit or explode over the sky of Los Angeles, it would destroy buildings over that same kind of area, 800 square miles or so. So it could completely wipe out a large portion of the Los Angeles metropolitan area.